What if I told you that right now, as you're watching this, something is happening in our solar system that might change everything we thought we knew about our place in the universe? Imagine this. You're an astronomer. It's a regular Tuesday night, and you're scanning the heavens like you've done 1,000 times before. But tonight, something catches your eye. An object that shouldn't behave the way it's behaving. An object that pulses like a heartbeat, steady, rhythmic, precise, every 7.1 hours. Like clockwork. And here is the thing that makes your hands shake as you reach for the phone to call your colleagues. Nature doesn't do clockwork. Nature does chaos. Nature does randomness. But this is different. Welcome to the story of 3IATLAS, and welcome to the week that might rewrite the textbooks. Let me paint you a picture of what's happening right now in observatories around the world. 5 days ago, someone noticed something extraordinary. 31ATLA, as an interstellar visitor that's been traveling through the darkness of space for who knows how long, has aligned itself in a geometric configuration with Earth and the Sun that happens so rarely we might never see it again in our lifetimes. We're talking about an alignment within 0.69 degrees. To put that in perspective, that's like trying to thread a needle from across a football field while both you and the needle are moving. And the astronomical community? They went into emergency mode. Picture this. Telescopes being redirected mid-observation. Astronomers canceling their sleep schedules. Emergency time being allocated on the Hubble Space Telescope and the James Webb Space Telescope. Why? Because we have 1 week. 7 days. That's it. After that, 3IATLAS continues its journey into the infinite darkness of interstellar space, and this opportunity vanishes forever. Think about that pressure. Think about what it means when the entire global astronomical community drops everything to focus on one object. When was the last time you saw scientists scramble like that? The discovery of gravitational waves, maybe? The detection of the first exoplanet? This is that level of urgency, and yet most of the world has no idea it's happening. Here's where it gets beautifully scientific and a little bit magical. On January 22nd, something called an opposition surge occurs. Now, I know what you're thinking. Opposition surge sounds like something from a sci-fi movie. But bear with me, because this is where nature gives us a gift we rarely receive. Imagine you're in a dark room with a flashlight. You shine it at a wall, and you see the light scatter everywhere, right? But now imagine you position yourself so that you're standing directly in line with the flashlight and the wall. Suddenly, the light bounces straight back at you, much brighter than before. That's essentially what's happening here, except the flashlight is the sun, you are Earth, and the wall is 3IATLAS, millions of miles away. During this opposition surge, we get to do something astronomers dream about. We get to scan the microscopic surface structure of an object from millions of miles away. The way light scatters back tells us whether the dust around. 3. Atlas is fluffy and primordial, the kind you'd expect from a natural comet that's been floating through space since the formation of the solar system. Or whether it's compact, processed, and structured in ways that don't match anything we've seen before. This is the cosmic equivalent of an MRI scan, and we have 1 week to perform it. But here's where the story takes a turn from fascinating to genuinely unsettling. Remember that 7.1-hour rotation I mentioned? Let's talk about what that really means. Natural comets tumble. They spin chaotically. They're irregular chunks of ice and rock that have been knocked around by gravitational interactions, collisions, and their own outgassing for billions of years. When you watch a natural comet, it's like watching a football tumbling through the air after a fumble, unpredictable, wobbling, unstable. 3I Atlas doesn't do that. 31ATLAS rotates with the precision of a Swiss watch, every 7.1 hours exactly. Its jets pulse in perfect synchronization with this rotation. The brightness changes are rhythmic, predictable, controlled. And here, as the part that makes astronomers pause mid-sentence. Its rotation axis points almost directly at the sun. Let me explain why that's weird. Imagine throwing a football randomly into the air 1,000 times. What are the chances that it would consistently point in one specific direction? Pretty low, right? Now imagine that football is also shooting jets of gas from its surface, which should be causing it to tumble wildly. Yet somehow, it maintains its orientation. It maintains its rhythm. This is behavior we see in satellites, in engineered systems with attitude control, in objects designed to maintain stability. This is not behavior we expect from a chunk of cosmic debris. As astronomers continued their observations, they noticed something else peculiar. 31ATLA started shedding mass dramatically. Water production spiked, which is normal for a comet approaching the sun. But then something unexpected happened. The ice signatures vanished. Imagine peeling an orange. At first, you're removing the outer peel, and everything smells citrusy and familiar. But then, as you keep peeling, you discover something underneath that doesn't look or behave like an orange at all. That's essentially what we're watching happen with 3IATLAS. What remains after the shedding is dark, organic rich material that behaves differently from any standard cometary nucleus we've studied. It's as if 3I Atlas wore a disguise and icy coating that made it look like a normal comet, and now that disguise is coming off, revealing something else entirely underneath. And here's another puzzle piece that doesn't fit: the anti-tail. Comets develop tails that point away from the sun because solar radiation pressure pushes the lightweight dust particles outward. It's as predictable as leaves blowing in the wind. But 3I Atlas has developed a tail that points toward the sun. The only way this happens is if the particles being shed are unusually heavy millimeter scale or larger. These aren't the fine dust grains you'd expect from natural fragmentation. These are chunks. Think about breaking a ceramic plate versus breaking a piece of concrete. The plate shatters into dust and fine pieces. The concrete breaks into chunks. 3I Atlas is behaving like concrete, like something with high tensile strength, something that snaps rather than crumbles. That's not typical of loosely bound cosmic rubble. That's typical of materials that have been processed, compacted, or even engineered. Now let's zoom out and look at where 3 Atlas came from, because this is where things get philosophically interesting. When astronomers traced its orbit backward, they discovered something that made them sit back in their chairs and stare at their screens. 31ATLAS came from what we call the local standard of rest. In simple terms, it wasn't orbiting a star. It wasn't traveling with the normal motion of objects in our galaxy. It was effectively stationary relative to the galactic background, just sitting there in interstellar space, waiting. This is unusual because most interstellar objects we detect are moving fast, having been ejected from their home star systems with considerable velocity. They're like cosmic cannonballs, shot out into the void. But 3 Atlas? 3-1 Atlas was parked. This has inspired what scientists carefully call a thought experiment, not a claim, not a conclusion, but a hypothesis worth considering. What if there are dormant probes scattered throughout the galaxy, positioned strategically and programmed to activate when star systems pass nearby? Before you roll your eyes, consider this. Humanity has already sent probes beyond our solar system. Voyager 1 and 2 are out there right now, carrying golden records with information about Earth, designed to last billions of years. We've done it with 1970s technology. Now imagine a civilization millions of years more advanced. Would it be unreasonable to think they might have done something similar, but on a grander scale? Here's where we need to pump the brakes and talk about responsible speculation. The internet has gone wild with theories. Some people claim the 7-hour pulse is a message. Others see patterns in the jet modulations and link them to everything from the WEO signal to ancient alien theories. Let me be clear. Periodic behavior alone is not communication. The sun rises every 24 hours. It doesn't mean it's trying to tell us something. Pulsars rotate with incredible precision. They're lighthouses, not telegraph operators. Pattern recognition is hardwired into human brains. It's why we see faces in clouds and hear messages in random noise. It's a survival trait that served our ancestors well when spotting predators in the bushes, but it can lead us astray when analyzing astronomical data. The scientists studying 3 Atlas are painfully aware of this. They're walking a tightrope between two extremes, dismissing anomalies too quickly because they seem too extraordinary, or embracing wild speculation without sufficient evidence. The truth requires us to sit in the uncomfortable middle ground, acknowledging that something unusual is happening while maintaining rigorous standards for proof. So why does this particular week matter so much? Because the opposition surge on January 22nd offers us a diagnostic capability we won't get again. If 3I Atlas has structural uniformity, smooth surfaces, instead of the fractal, irregular topology of natural comets, this alignment will reveal it. If there's modulation in its behavior, beyond simple rotation patterns that might indicate internal mechanisms or active processes, this geometry maximizes our ability to detect it. Think of it like this. Imagine trying to examine a piece of fabric to determine if it's hand-woven or machine-made. From far away, they might look similar. But if you could shine a light at exactly the right angle and examine how that light scatters through the weave, you could tell the difference. That's what we're trying to do with 3I Atlas, except the fabric is millions of miles away, and we have 7 days to complete the examination. As 3I Atlas prepares to leave our solar system forever, a question emerges that's both practical and philosophical. Should we follow it? Project Lyra is a conceptual framework for exactly this kind of mission. Using current and near-future propulsion technology, it would be possible to launch a spacecraft that could catch up to 3 Atlas within a few decades. The mission would require tremendous energy, enormous cost, and international cooperation on a scale humanity has rarely achieved. But imagine their return. Imagine a probe catching up to 3I Atlas, deploying instruments, conducting close-range analysis. Imagine finally answering the questions that have kept astronomers awake at night. Is this an exotic but natural object, formed through processes we don't yet understand? Or is this something else entirely evidence that we're not alone, that other technological civilizations have existed or still exist in our galaxy? The data from such a mission could reshape our understanding of planetary science, interstellar chemistry, and our place in the cosmos. It would be the scientific equivalent of the moon landing, perhaps even more significant. The question is, do we have the courage, the resources, and the collective will to pursue it? If there's a lesson in all of this, it's that the universe rarely conforms to our expectations. We imagine first contact as dramatic massive ships appearing over major cities, radio signals that are unmistakably intelligent, undeniable proof that makes headlines around the world. But what if it's nothing like that? What if contact is subtle, ambiguous, requiring years of careful analysis to even recognize? What if it looks exactly like this? Data plots, peer-reviewed papers, scientists cautiously presenting arguments, heated debates in academic journals, and a slow realization unfolding not in headlines, but in the quiet, methodical accumulation of evidence? This might be what genuine discovery looks like in the real world. Not a moment of revelation, but a gradual dawning of understanding. Not certainty, but probability. Not proof, but compelling correlation. And here's the beautiful, frustrating truth. We might be living through that moment right now, and most of us won't even realize it until historians look back decades from now and mark this week as the beginning of something profound. Let's ground ourselves in facts. Here's what we know with confidence. The alignment is real. The geometry between Earth, the Sun, and 3I Atlas is exceptional and time-limited. The object is unusual. Its rotation is stable and precise. Its mass loss pattern is abnormal. Its particle size distribution doesn't match natural fragmentation. Its origin point is statistically odd. Multiple explanations remain viable. This could be exotic interstellar chemistry we haven't encountered before. It could be unusual ice phases or dust properties produced by conditions we don't yet understand. Or it could be something else. The next step isn't belief, it's patience. It's waiting for the post-January 22nd analyses to be completed, peer-reviewed, and published. It's letting the scientific process work the way it's supposed to work. Slowly, carefully, with healthy skepticism and rigorous standards. So what's the takeaway from all this? What can we learn from 3I-ATLAS that applies to our everyday lives? First, stay curious but skeptical. The universe is full of wonders we don't yet understand, but extraordinary claims require extraordinary evidence. Don't dismiss the unusual, but don't embrace wild speculation without proof. Second, appreciate the process. In a world of instant gratification and clickbait headlines, there's something profoundly beautiful about watching scientists methodically work through a genuine mystery. They're not giving us answers. They're showing us how to ask better questions. Third, recognize that the most important moments might not feel important while they're happening. History is made in quiet rooms with careful measurements, not always on grand stages with dramatic announcements. And finally, remember that we're all part of this story. Whether you're an astronomer or someone watching this video during your lunch break, we're all inhabitants of a solar system that's been visited by something we don't fully understand. We're all witnesses to a moment of genuine cosmic mystery. So here's my question for you. If we definitively proved that 3I Atlas was artificial, a probe from another civilization, how would that change your perspective on life, on humanity, on your daily struggles and dreams? Would it make our problems seem smaller, or would it inspire you to think bigger? Drop your thoughts in the comments. I genuinely want to know what you think. And remember, whether 3 Atlas turns out to be an exotic comet or the most significant discovery in human history, the fact that we can ask these questions, that we can point our instruments at the heavens and attempt to understand what we see, that's the real miracle. If you found this story as fascinating as I do, hit that subscribe button.